What's up, guys? This is Anthony Nunez. You may know me as Mornaris, and I'm bringing you the first lecture in a series on learning to program. This lecture specifically is going to be going over variables, statements, and functions. As you guys probably already know, I'm a student at Florida International University, part of the College of Electrical and Computer Engineering, studying computer engineering. And hopefully this series will bring you one step closer to programming, being able to program, having knowledge that will help you pick up a programming language, a coding language, such as C++, Java, Python, you name it. With the knowledge that you will learn here in this video series, you should be able to pick up one of those languages, learn the syntax very easily because you will already understand the underlying components from the programming language, because programming is universal while languages are specific. So let's begin. Well, I have to click. Okay, there you go. So first of all, what is programming? Well, simply, it is modeling problems using computer science concepts such as variables and functions, which we'll talk about in this video. Creating algorithms in order to solve these problems, and then programming a system such as a computer to solve the problem using the given algorithm. It's that simple. It's very, very easy to kind of wrap your head around programming, right? Specifically in this series, we're not going to be getting into the part about programming a system, because that's when you start talking about C++, Java, Python, these kinds of languages that you actually use to code your solution into a system, which is part of the programming process. We're going to be sticking to the first and second bullet points here. That's what we're going to be doing here in this series. So what is an algorithm, you may be asking yourself? Well, simply, it's a logical series of steps which model a solution to a problem. The typical example of this is how to make a PB&J sandwich. Well, you need a series of steps that show you how to make a PB&J sandwich. These steps are, actually, if you think about it, can be quite simple, quite complex, however you want to see. For this purpose specifically, we're going to keep these simple and to the point. First, we want to place 2 slices of bread on the table. All right, simple. Then we want to use a knife to place some peanut butter on one slice. Use a knife to place some jelly on the other. Put the 2 slices together, and then place the sandwich on a plate. Simple. This right here is an algorithm. It's a series of steps which help us solve a problem, right? So algorithms are universal. They're not specific to programming, but they're a very pivotal part of programming that we need to kind of focus on to kind of really understand how it is that we're going to take these problems, solve them, and then program solutions for them. And that's an algorithm. So variables model the characteristics of a problem or object. Right, so how do I find the sum of 2 numbers, right? This is a problem that we're trying to solve here, and this problem has components, right? If we're trying to find the sum of 2 numbers, we're going to need one number, we're going to need another number, and we're going to need the result, right? So we're going to add 2 numbers together, we're going to get a result. All 3 of these things are components of the given problem. So then we talk about variables, right? Variables hold data, such as numbers, and the result of the addition problem from the last slide. All of these data points, right, these pieces of data have a data type which must be taken into consideration. This is a very important part of some languages such as C++, where type safety is very important, and eventually we will get to type safety once we start getting deeper into the more advanced topics of this series. So for this programming course, we're actually going to keep the list of data types short and to the point. We're going to talk about integers, doubles and floats, characters, strings, and Booleans. Very simple. So integers, doubles, and floats. These are your number storage variables. You're going to be putting numbers inside of these variables that have the data types of integers, double, and floats. Before we continue, actually, I want to specify that the difference between doubles and floats is that floats actually store smaller numbers than doubles. Doubles can store the same capacity as floats and more. So if you're going to be storing a humongous value, then you're going to want to use a double versus a float. So here, integers store whole numbers, including negative numbers, and doubles and floats store numbers with decimal values. So you can store 0.17 in a double or a float, and you can store something like 27 in an integer. Moving on, we have characters and strings. A character is simply a simple character. It's an A, or a slash, or a dot, or a plus. Very simple to understand. A string holds a string of characters, such as a word, sentence, paragraph, etc., such as hello there, people. That's a string, right? A string of characters. We have an H, we have an E, we have an L, L, O, we have a space, we have a T, H, E, R, E. Those are characters. Another space, P, E, O, P, E, L, E, exclamation mark. Those are all characters. This is a string of characters, and that's the string. So you kind of want to pay attention to the fact that a string is based off of characters, right? Makes sense. And then finally, we have Booleans in this list. They hold two values, true or false. Right now, I'm not really going to get into the technical aspects of this as to why you care about true or false. Actually, we're going to talk about that in more detail once we get to if-else statements and loops. Once we get there, then it makes a lot more sense as to why we have Booleans and why we use Booleans. So next we have statements. A statement is simply one part of an algorithm which gives some instruction. For example, we have the add the values of two given values. That's a statement. Store that value in a variable. That's a statement. And then we have variable declarations. This is a type of statement that's very important to programming. Variable declaration is the act of declaring a variable in its data type. You have to declare variables and you have to declare their data types. Additionally, these variables can be initialized at the moment of declaration. This is basically the process of giving it an initial value. So I just declared a variable of type integer, and I'm going to give it some initial value to begin with. I can then later change that value, as you will see in the following slides. But here's the initial value. Here's what it is at the moment of declaration. So here we have a variable declaration in simple pseudocode style. We have the variable declaration, and we have the initialization. Part of the variable declaration is the data type, in this case integer, and then the name, in this case num_a. So now we have an integer variable called num_a, and it's being initialized to an initial value of 23. Then we have something called the assignment operator. The equal sign is known as the assignment operator. It assigns a new value to a variable. It's that simple. If we have a variable num_a that is equal to 2, and then I say in a following statement, num_a is equal to 7, I just assign the value of 7 to num_a. So num_a is no longer equal to 2. Now it's equal to 7. So pay very close attention to that fact when you start reading long lists of statements and you have a lot of math going on. You want to really pay attention to where the assignment operator is used because it will override the previous value held inside of that variable. Checkpoint. We have a list of statements here. We have 3 variable declarations. We have 3 variable declarations and initializations. And then we have a statement here that says that num_c is equal to the sum of num_a and num_b. So I ask you the question, what is the value of num_c? I'm going to give you 5 seconds. You may want to pause the video if you want to do this on your own. The answer to this question is 5. Here's why. In the first statement, we declare the variable num_a of type integer and initialize it to a value of 2. In the second statement, we declare num_b as an integer and assign it, initialize it to a value of 3. And then we also declare integer num_c and initialize it to a value of 10. However, here in the fourth statement, we use the assignment operator to assign the sum of the first 2 variables to num_c. So using basic understanding of mathematics and substitution, num_a is equal to 2. Num_b is equal to 3. I sum 2 and 3, I get 5, and then I assign the value of 5 to num_c, so the value of num_c is 5. Next, we talk about functions. Functions are very, very simple to understand. But first, we have to look at the anatomy of a function. So if you see here at this diagram that I made, we have a function. This function is called sum. It has a function name. It has 2 parameters, the arguments num_a, number a, and the argument number b. So it has 2, argument 1, argument 2, number 1, or number a, number b, kind of slow down a bit here. And then we have an instruction set. It simply states return the sum of number A and number B. The return value is the sum of number A and number B. So again, return value. The instruction return the sum of those two numbers. Obviously here, we didn't feed it actual numbers, so we're just using this arbitrary placeholder. Then we're going to look at a function declaration. How do you declare a function when you're talking about programming? First, you're going to give it a return type. This is the type of data that it's going to return to you. Then you're going to give it a function name, in this case, sum. And then you're going to give it a list of parameters, if any. You don't have to give it parameters, but if you do want to, you have to declare it during the function declaration. In this case, we have two arguments that are our parameters. We have num A, num B. They're both of type integer. Remember, we always have to declare the type of variables, even when we're declaring them here. So it's very important that we understand a very important point about declaring the parameters of a function. These variables are declared here, and then they can be used inside of the function, as you will see later on. So we'll cover that you have to give a function values, right? Just like in mathematics, right? If you have f of x, you have to give it an x value to get back a y value, right? The f of x is equal to y. You have to give it an x value to get back your f of x, right? So in this case, we have to give it a quote-unquote x, right? In this case specifically, we have to give it two arguments, something for num A, something for num B, right? So we have to give it two integers. One of them will be stored in num A, one of them will be stored in num B, and then they will be used during the instruction set of this function. So for example, here in the top we have a function called sum of return type integer. It takes two arguments in its parameters, num A and num B, and then it will return their sum. Here in the bottom though, we have another example. We have a function called add2. It's of type integer, so it returns an integer, and then it has the same two parameters. However, the instruction set is longer. The first thing we do is that we take num A, so whatever the user gave it, and we're going to take that original value and add 2. And then we do the same thing with num B. We take the number A. So remember the assignment operator, right? So let's say num A was 3 to begin with. We added 2, that's 5. Now here, we take that 5, add 2, that's 7, and assign it to num B. So now we have 5 and 7 stored in num A and num B, and then we return their sum, which is going to be 12. So then we also have to think about function calling. We have to call a function into our instruction set. Otherwise, it does nothing. You can declare a function and its instruction set and not call it. And if you don't call it, it won't do anything. So here, what do we have? We have the declaration of a variable. Num_d of type integer is equal to 2. We have num_e equal to 3. And then we're saying that the declaration of num_f is being initialized to whatever the function sum is returning when its arguments are num_d and num_e. So what does this mean? It means that we're passing 2 to the function. We're passing 3 to the function. It's going to take the sum, because remember we already declared a sum function like a slide or two ago. So it's going to return the sum of its parameters. So it's going to be 2 plus 3. It's going to return that value. So this whole function thing, this whole function call here, is going to be equal to 5 now, because it returned the value. It gave us the value of 5. That we're then going to use the assignment operator to assign the value of 5 to num_f, and now num_f is going to be initialized to the value of 5. Again, this is called a function call. We have to call the function, give it the proper arguments, and it will give us back a value as needed. Then we have a special type of function. We have void return type. So we know, for example, from the variable types that we learned, we have integers, we have doubles, floats, we have chars, characters, we have strings, we have booleans, and we can return these types of data from functions. However, there is a new function type that I need to introduce you to, and that is the void. The void return type means that the function will return no data. It will not give me back anything. However, it will still conduct its instruction set. It will move through the steps in its instruction set. However, at the end, it won't return anything. For example, we have here a function called print on screen. and it takes a string message as a parameter, and then simply the instruction is to print whatever message is on the screen. We then call print on screen, giving it the parameter or argument of hi, and then that's the function call, and it will just print hi on the screen. Well, that, little discrepancy here. Now, I want you to note something very specific about this function call. We don't have a variable in front of it. We're not assigning anything from here to any variable because remember, this is void. It's not going to return anything. So when we call void functions, we call them on their own. We don't have to put them on the other end of an assignment operator. We don't have to put them in other kinds of situations. We simply put them by themselves, and that will call the content. That will simply just go through the instruction set, doing whatever the instruction set is on its own, and it will not return a value. So checkpoint. Again, you might want to pause the video if you want to do this on your own, and then we will see what the answer is, and then I will proceed to go step by step explaining the logic here. So here we have two functions. Two function declarations. The first one is sum, takes two parameters, returns the sum of them, print on screen. Again, it's the same print on screen, makes a lot of sense. But then here we're calling print on screen, and then its parameter is the sum. We're calling sum now with arguments 3 and 5. So what will print on the screen? I give you a hint. Remember substitution. It's very important. We give you 5 seconds, pause the video if you need more time, and then I will show you the answer and we will go through this step by step. The answer is 8. So now let's see why that is. So here we call the print on screen function. It requires a string message. So instead of giving it a string, we're calling the sum function, giving it a 3 and a 5. It's going to return to me an 8. So now there's an 8 here, right? Because remember, we can substitute, like I said. So sum, we call sum, give it a 3 and a 5. It returns 3 plus 5, that's 8, right? So now we have an 8 here. An 8, when we pass it as a string, right? Even though it's an integer, we're passing it as a string, right? It'll just be like saying 8, right? It's a string, 8. It's not a number. It is a number, but it isn't, right? Because we're talking about a string here. It's a character 8, not a number 8, right? So then we're passing the character 8 to the print on screen function, and then that will proceed to print 8 on the screen. So that's what would happen. So thank you so much for watching this video. I hope you learned a lot. If you have any questions, put them in the comment section. I will get back to you as soon as possible. Remember to study, watch the video over if you need to. Now, if you want to follow me and hear more about what I have to say, see what I have to teach you, and all kinds of other shenanigans, follow me on Twitter at Mornaris. And also feel free to check out my portfolio website over at http:// don't even have to say that really. Anthony-Nunez.me. Don't put the little tilde thing on top of the end though, because that will not take you anywhere. So again, thank you so much for watching. I hope you learned a lot. This has been Anthony Nunez bringing you the first lecture in the Learning to Program series. Signing out. Signing out. Signing out.